Hello, friends. This is Jim with Science Talk. I have a report to bring with you that discusses the massive retreat of the Pindari Glacier in the Himalayas. The snout of the Pindari Glacier in the upper Himalayas of the Kumaon region and the source to the Pindar River, which is a major tributary of the Alaknanda River, has retreated over 4 decades. This is based on the latest research that adds to the data that officially confirms the loss of this glacier. The findings of the joint research by scientists from the Kumaon University, the Nainital Uttarakhand Space Application Center located in Dehradun, and the Indian Institute of Science, Education and Research located in Kolkata. Basically, they're laying the groundwork for more rigorous scientific studies on quantifying the glacier retreat. They've done basically rudimentary measurements, as I'll get to in a moment. So they want to do better quantification of the retreat of the Pindari Glacier as well as other glaciers in the Himalayas. Their report has just been published in the journal Remote Sensing and Environment. So just to give you a little brief background on the methodology that they employed, the scientists assessed the retreat of the Pindari Glacier from 1976 to 2014, basically nearly 40 years, 38 years exactly, using visual interpretation of remote sensing data. They use global positioning system coordinates to determine the latest position of the snout in 2014, and then mark the location of the snout using a series of periodic Landsat images, and then they manually digitize the records and the data. Okay, so basically what they did was they noted the location and they tied it into coordinates so that they can say, oh, okay, we know it has retreated this amount from here to this other location. And Landsat is a satellite that goes overhead, takes some images, sends it back down, you download it, and you can then do your analysis. They marked the snow area and snout point for different years using the satellite data, as I just described, and compared the data sets to measure the changes in the glacier position and the distances to which the glacier shifted. Again, this is with the help of the GPS. The scientists reported that the cumulative glacial retreat was 1,569.01 meters over the 4 decades. Basically 1.6 kilometers in essence. Now, 1.6 kilometers is about a mile. They also noted that the average glacial retreat was 51.23 meters each year within the study duration. The annual glacier retreat rate was faster during the period from 1976 to 1994 than from 1999 to 2014. So that is interesting. It makes you wonder if there are other factors at work, such as the topography, any drastic changes in elevation. It would be interesting to see what the reasons for that is. The report concludes that high priority research funds should be allocated to conduct similar assessments in other mountain ranges situated across the entire Himalayas. Gajendra Singh Rawat, who is a scientist from the Uttarakhand Space Application Center in Dehradun, one of the study authors, said that while his team has not analyzed the glacial mass balance, they have used actual ground truth points for some years and also used, basically they went to observations of people, and basically said, okay, where do you remember seeing this? Granted, it's not precise, but it does give you an idea. And in addition, they use the remote sensing data. And the truth points are basically verified reference points. That's what a truth point is. A verified reference point that you have an actual measurement at this precise location, and you can then revisit that and note any changes. Now, a word about glacier mass balance. They noted that the glacier retreated 1.6 kilometers. Okay. They did not really measure how much mass was lost. I could have a glacier, let's say, just for argument's sake, I have a glacier that's 50 meters wide, and it retreats 1.6 kilometers. How tall was it? Was the glacier 20 meters tall, 100 meters tall? That obviously gives you, if you calculate 1,600 meters by 50 meters by, say, 20 meters, that gives you a certain volume loss, or 100 meters, that give you another volume loss. So you see what I'm getting at with the glacier mass balance. It's basically, they didn't really know the thickness of the glacier to calculate how much ice was actually lost. That's the key point I'm trying to get here. He goes on to say something very interesting, and this is a point I have made in other videos, other segments I have done, where I talk about glacier retreating and so forth. Small streams around the glaciers are accelerating the retreat process because, as I mentioned before, if you have, like, say, water spiraling in, like drilling a hole through the ice, eventually it'll go all the way down to the bedrock, and you have this water, liquid water, now lubricates the bedrock, and that can accelerate glacier movement. Small streams around the glaciers accelerating the retreat process. Most likely this water, these streams, are getting into the bedrock and providing a lubrication. So scientists linked Pindari's and other Indian Himalayan mountain glacier retreat to climate change and cautioned over the implications for water storage in the region, because the Himalayas are lifeline of water to at least two major Indian rivers, the Ganges and the Brahmaputra. The Ganges and the Brahmaputra. So these rivers and the people that depend on these rivers rely on a slow melt rate to provide their water needs. If you lose the glaciers, you're not going to have that water available later on. And this is a problem we're seeing not just in the Himalayas, but across the Alps in Europe and other, such as the Rocky region in the North American continent. Places rely on a slow melting of the snowpack from the winter to provide the water needs for the following spring and summer. You lose the snowpack, you lose the ice, you don't have that water, things start drying up. That presents problems. Pindari's retreat of about 1.5 kilometers estimated over a 1.6, over a 40-year period is consistent with what is happening to mountain glaciers around the world due to climate change, said Govindasamy Bala, who is a climate change expert and professor at the Center for Atmospheric and Ocean Sciences at the Indian Institute of Science in Bangalore. The consequent decline in the volume of water stored in this glacier could have major implications for water flowing in the Pindari River, for the reasons I just outlined for you. The retreat clearly indicates the effect of historical warming. He goes on to say, I'm still quoting from Professor Bala. If the greenhouse gas emissions continue to increase, it is likely that the retreat would accelerate in the future. The long-term decline in the glacier volume could have devastating effects on water resources in this region. There could be also threat from glacial lakes that form from the glacier melt. Basically, what I think he's getting at here with the glacial lakes is that you could, in say, low-lying areas or areas that where water can accumulate, you might then have a result of some natural earthen dams. The earthen dams break, and now you have this cascade of water that can come down and basically have a flash flood. I think that's what he's getting at there. This new research is consistent with other recent research findings from the Himalayas. For example, in 2017, a team of scientists from the Indian Space Research Organization and geologists from Andhra University in, okay, here we go, Visakhapatnam. I totally butchered that. It's a very long word. Visakhapatnam, led by ISRO scientist Babu Govindraj K, reported in Geomatics, Natural Hazards and Risks that Himalayan glaciers are showing reliable evidence of climate change. These scientists had mapped the glacier status in Bilanga Basin of Garhwal Himalayas and also in the state of Uttarakhand using Corona and Cartosat satellite images acquired between the years 1965 and 2014. So they were able to go back even a little further back in time. The Binlangna River is the southernmost tributary of the Bhagirathi River and joins it near New Delhi. They reported that the main Katling Trunk Glacier that receded by 4,340 meters had fragmented into multiple valley glaciers, increasing the number of glaciers in the basin from 20 to 33, and about 10% of the glacier area was also lost from 65 to 2014. Well, the thing also is when you fragment these glaciers, you are increasing the surface area to volume ratio, meaning that you can accelerate the melting process. I mean, if I have a big chunk here, okay, there's only so much surface area that can be heated up. But if I have the same chunk here, the same volume, but I split it into smaller bits, well, now I have the sides here and so on. I've increased the surface area to allow more heating to more rapidly melt it. That's basically what they're saying. More studies dealing with loss of glaciers in the Himalayas. A team from the Indian Institute of Science Education and Research located in Pune reported in the Annals of Glaciology in 2016 how glacier lengths have been changing in the Himalayas. The ISER Pune team had analyzed changes in the length of 43 glaciers, including the Pindari, across the Himalayan and Karakoram ranges. These are real tongue-twisting names. During the period from 1850 to 2010. Well, if you're going back to 1850, this is obviously eyewitness reporting. I would be cautious in using the data unless it's really been excellently quantified. I'd be a little suspect about that. It can be at most anecdotal. That's just my opinion. The analysis revealed that Himalaya and the Karakoram has warmed up about 1.5 degrees Celsius over this period, and again, this is consistent with global glacier retreat since the Little Ice Age. Now, I have presented videos segments for you in the past where I've discussed the Little Ice Age as well as the Younger Dryas period, so you might want to go check those out if you're so inclined. In their paper, they refer to other published estimates of the retreat of the Pindari, which suggests a total retreat of a little over 3 kilometers from 1906 to 2010. This means a long-term retreat rate of almost 30 meters each year over a period of 104 years, said Arka Banerjee, who is assistant professor at the Division of Earth and Climate Science at ISER, located in Pune. Banerjee, however, has some reservation about the new 2018 study on the Pindari Glacier. One is the absence of estimation of uncertainty of the measurements. Okay, you just heard me say a few moments ago where I say we need to consider this information carefully. It might be anecdotal, it might not be precisely quantified, and this is kind of what he's getting at here. So we do not know about the accuracy of their numbers. Banerjee also pointed out that the scientists have not compared their data with other data on the Pindari Glacier. Now, like anything else and any time presenting data, you really should present errors associated with the data. I just did I've done a bunch of videos on statistics, intro stats, and I talk about error measurements and so on. You really should be doing that. For example, oftentimes you might see scientists measure something, and they present the mean, whatever it might be, and they might give you a value of something like 53.4 plus or minus 3.8. The plus or minus is your error. Typically, it might be standard deviation, could be standard error, but it is an error, giving you an idea of the range. I've done other videos where talking about CO2 levels in the past, that the further back in time you go to try and ascertain or get a handle on the CO2 levels, there's more error involved with it, so we have to be really cautious in how we assess that data. But that's part of the analysis, that's part of doing science, and a good scientist, a good scientific report should and would include such information. Banerjee does acknowledge that the long-term retreat is indeed an undeniable sign of climate change. He does caution against looking at only one glacier. And he's right. And as I noted earlier, the science is basically saying we need to look at the other glaciers. And yeah, we do that, then you have comparison points. Glaciers are like thermometers. They shrink as the temperature increases and vice versa. Okay? Their shrinkage can be utilized to read off a temperature change if one knows the scale or calibration of this thermometer. Okay? Little pop up there. Unfortunately, such calibration formulas are known to us only approximately. Therefore, to construct accurate climate signal, one has to consider a large number of glaciers spread across a large geographical area. I totally agree with his assessment on this. He's right. A single point does not make a trend. 2 point, maybe. A whole lot more points, yeah. And that's basically what he's getting at. Bala said that, similar to sea level change, glacier formation or melt is a very slow process in the climate system. Therefore, if greenhouse gas emissions take the business as usual trajectory, climate warming is likely to result in irreversible change to the Himalayan glaciers and the natural and human systems that are associated with them. Okay, can't really argue with that statement, but I think Professor Banerjee's point is well taken. Get more information. That's basically what he's saying. Get more information, then we can cross-correlate the errors, the observations, the data, and make a better assessment for the region as a whole. So I just wanted to bring you the story from this region of the world that you probably don't hear much reported on, the Himalayas, but the Himalayas do contain a significant amount of ice as well. So, and it does affect the people there of that subcontinent down below. So, just another example of the changes that are ongoing, and basically what's happening across the planet due to the burning of fossil fuels. Thank you for your time. Hello folks, this is Jim asking for your help. I want to grow this channel significantly. I want to increase the number of people who subscribe to my channel. I want to increase the number of people who are supporting patrons on Patreon for this channel. Patreon.com/Science Talk with Jim Massa. I do not receive funding of any sort from anyone. So the information I share with you is the information as found published in the peer-reviewed journals. No propaganda, no BS, just the science, and of course I give you my interpretations and analyses based on my experience as a scientist. So please tell others of the work I do here, tell others of my channel. Share my videos, post them on other social media platforms. But we need to disseminate this information to more and more people, to a wider audience. And I need your help in doing that. For those of you who are already patrons and support me on Patreon, thank you. Thank you for your support and continued support. Together we can do this. So you'll find details in the description box below, how to support me on Patreon. And thank you. Thank you for your help. Thank you for your continued support. It does mean a lot to me. We can do this.